G'day guys, welcome back to the channel. On this episode, I walk you through the process and cost of making my own adjustable chromoly long arm rear trailing arms. So, why am I making my own trailing arms? Well, every time I would attempt a rock step, my trailing arms would get hung up on the rock, and due to the factory arms being so thin walled and small diameter, they would bend. I tried to bend them straight over and over again. In doing this, my pinion angle was misaligned with the gearbox output driveline and making my pinion seal leak diff oil constantly. I researched everywhere I could and I couldn't find adjustable trailing arms that would fit my Jackaroo. The trailing arms I'm about to show you would work in any car that has trailing arms. You would just have to tailor the lengths and dimensions to your application. So let's get into it. This is how I did it. First thing I did was chock the front and rear tyres to prevent the car from rolling away when you take the drive shaft off. I went ahead and removed the 19mm nut and bolt from the front and the rear that join the trailing arm to the mount. Once I remove the bolt from the mount, I like to screw the nut back on the bolt and keep it handy so I don't lose them. Then I repeat the process for the rear and also the passenger side. Once the trailing arm bolts are removed, the arm is free to then fall down. I had to be cautious of the arm dropping onto my head. There is also a 10mm bolt holding the handbrake cable onto a bracket that I had previously undone from the trailing arms. Then just repeat the process for the passenger side. I had to get a hammer onto a spanner for the rear one, it was fully seized, but eventually I got it off. Up next, I removed the tail shaft from the gearbox to the rear diff. I wrapped a ratchet strap around the diff and to a cross member to stop the diff from rolling, as there is now only one top trailing arm connected. The diff is now free to roll, and this is how I was able to adjust my pinion angle. The tail shaft is held in by 14mm nuts with a bolt that is secured by a flange lip on the back of the mating plate. I used a rattle on very low torque to undo these. You could also use a 14mm spanner and a pry bar to hold the tail shaft from spinning. Once all the nuts and bolts are removed, you can either give it a little tap with a mallet, or I've undone mine recently so it just popped off easily. Now we come to the rear of the gearbox where the mounting plate meets the drive shaft. Repeat the process and remove the drive shaft completely. I picked up this digital angle gauge from my local tool shop. It was only like 80 bucks. So I zeroed the gauge on the gearbox tail shaft mounting plate. I then took the gauge down to the rear diff tail shaft mounting plate to see what my pinion angle is in relation to the gearbox output. This is very important so that your drive line is running true. This is what I used the ratchet strap for. I was able to roll the diff forward or backward in relation to the pinion angle to zero it. Now both the gearbox and pinion were level with each other. I could take some measurements to figure out the length I needed to make my trailing arms. I put the bolts back in the brackets and measured from the outside edge of the rear bolt to the inside edge of the front bolt. This gave me a measurement of center to center of the holes in the mounts. Next step was to lay out all my parts and record the measurements I had taken from the diff to chassis mounts. This would allow me to work out how long I needed to cut my tubing. It was important for me to get full thread engagement for strength of the Heims joints to the tube. I threaded on the locking nut to the Heims joint, then threaded on the bung until it had full thread engagement. I measured from the lowest fixed point on the actual joint to the chamfer on the bung, then measured the internal diameter of the Heims bolt hole and halved it for the center of the hole. I added these two measurements together and doubled it because I have a joint at either end. then subtracted that total from the overall measurement I took from the diff to chassis mount, and this gave me my tubing length. For example, the overall bracket dimension center to center was 878mm for both sides. Fixed point on the heims to chamfer was 64mm. The internal diameter of the bolt hole was 25mm, then I divided that by 2 to get the center. 64 plus 12.5 gave me 76.5mm. Times that by 2, because I have a joint at either end, that gave me 153mm. So 878 is the total overall hole to hole on the car, minus 153, which is the 2 joints at either end, gave me 725mm. This would be my tubing length for the full thread engagement. Now it was time to cut. A little trick I used, from the line that I marked with the square, I run a bit of tape straight around the pipe, and it'll give you a straight edge when you're cutting with the grinder. Once it was all marked out, it was time to cut. I just used the flat disc to clean up around the outside diameter and the inside diameter, just to give it a little chamfer and get rid of any sharp edges. I then put the bung up against the tube to see how far they would recede in. I marked the center of the depth of the bung and used my center punch to punch an indent ready for drilling. I used my small drill press to drill a pilot hole, then a 7mm drill, and finished the chamfer off with a 13mm drill bit. These would be for strength, so I could weld what is called a rose joint. Time for welding. I have to give a big shout out to Ben for lending me his TIG machine. I wouldn't be able to complete this project without his help, so thanks Ben. I set up a camp table and chair and started to weld the rose joints first. Ben told me with 4130 chromoly it is vital to preheat the tube before welding, as to avoid cracking of the weld and steel and for optimum weld penetration. Once the rose joints were welded, I could run a weld around the bung and tube to finish off the arms. It is also important with chromoly to let it cool slowly after welding, so we let it sit for a good half hour or so until it cooled naturally. Then it was time for fitment. Now the tube had cooled, I could thread in the heim joints and test for interference or thread binding. It all went smoothly. They turned out really good. I'm very happy. It was now time to set up the tubes to the correct length and install them into the car. Once installed, I tightened down the bolts on the front and rear brackets. Now for setup of the pinion angle. I zeroed the gauge again on the gearbox side, took it down to the diff side, and then I could start to adjust my control arms. First thing I did was witness mark the Heims joints to the tube with a straight line. That way, when I rotated the tubes, I would know how far around I had rotated them. Ben was watching the angle gauge on the pinion as I turned the tubes, and we worked together to zero the pinion angle. Now that the pinion angle was zeroed, I could tighten up all the locking nuts and it was set. I put the drive shaft back in, I tightened up all the nuts, and the project was completed. How good's that? I'm stoked. I couldn't be happier with the outcome of these trailing arms. It was definitely a challenge, but good fun, and it was good to do it myself because nowhere else makes them for the Holden Jackaroos. Now where did I get the products to make this? There's a company called Racetech Steel, racetechsteel.com.au. I scrolled down to find my 4130 chromoly. We want tubing, and then I went down to the 50.8mm outer diameter. I went down to a 6.3mm wall. I ordered 2 meters of this. It cost me around close to $400. Next I went to a company called Design Fab, and you can select what joints you want. I went to Heims joints obviously, and I went 1 1/4 inch thread with a 1 inch nylon hole. So that's around $69 a heim joint. I had to get 4 of those, 2 left, 2 right hand, and then you can get all the associated lock nuts and spacers for them. Just a note, when you order heim joints from this website, they give you the locking nuts with the joint, and it cost me close to $500 for all of that. So that's it guys, thanks for watching. It cost me about $1,000 to make my own adjustable arms and about 3.5 hours to make.